Good morning. Can you hear me? Good morning.
Good morning, sir. Yes, we can hear you, sir.
So last week we have discussed about some quality management tools, and we have finished all the 7 quality tools. So under the quality management tools we discussed. We have discussed these 7 quality tools in detail. First, check sheets. You know the difference in between and tally sheet. Tally sheet means it's quantitative one, and the Pareto charts. So I hope that you all can do this, develop these Pareto charts also, and so there are different stratification techniques are available, but we have to do the stratification based on our experience and the available data. And the next thing we have discussed, histogram. It is very important, and we have conducted. I was explained you about the how to use Excel for histogram, and we have to do some analysis. I will explain these all these how to perform and develop all these tools through Excel at the end of this lecture series. And cause and effect diagram, it is also very familiar. There are several similar names are also available, such as fishbone diagrams, right? Then scatter diagrams. Scatter diagram, you can see a picture here. So how to develop scatter diagrams also very important. And control charts, it is actually there are some similar things in histogram and control charts. So by using histogram and histogram and control charts, we can check whether the process is inline or outline. Inline, or there are there any exceptions? So if it is, so we are going to develop our own limits. It means critical limits, lower control limits, and upper control limits. So I think this all these 7 quality tools are very important, and you have very good knowledge, and you all can develop and use these quality tools in your day-to-day. So I am not going to re-explain these things today. So if you have questions, we can discuss later, and you better to practice these things yourself. And I will explain how to do these things by using Excel at the end of this lecture series. So today we are going to move to the the new part. So today we are going to discuss about a new topic about hazards. So I think it's very important, hazards also. I will explain how to do identify hazards, everything. So in this picture you can see this is actually a picture related to our theme aircraft, and a natural picture here. So you can see some hazards here. So I just use this picture to give you a an introduction by using this image. You can see what happened in this aircraft. So hazards are there everywhere. We have hazards. So hazard identification and analysis is very actually, as we are BST people. So as I explained you in the first day, so the agriculture people, food and IBST, we all have to get together and work, because the agriculture people, they have to produce their crop, and after the crop to a product we can do, and there are some extractions and value addition. So we need IBST people support. So we all can work together, and all these things are very important, not for food, not for agriculture, and not for IBST people. So we can work together. Right here, you can see the hazards, and nowadays we also have some hazards in our faculty due to COVID symptoms of the students, because we have conducted some practicals physically in the faculty, but unfortunately there were some COVID patients in our faculty, and the student behavior also not good. So we have to stop all the practicals and ask them to go back to homes. And the boys are now in the quarantine stage. So hazards are everywhere, but we need to get those things clarified, and we need to ready before it becomes to a before coming to the hazard, right? You can, I think these pictures are very familiar with you all. There are different icons, international recognized icons are available for hazards, right? I'm not going to explain, and those things are very familiar. So you know this mark, and peroxide hazards and flame and radioactive hazards are there. So all these hazards, there are international recognized marks and symbols. So we need to we have to use these things. And hazard. So what is a hazard, right? Actually, a hazard is a potential thing, right? In this first picture, you can see a shark. And the second picture, you can see someone is swimming, and a shark is also there. And there are two words, hazard and risk. So hazard means, we know when we go to the or swimming or anything, there are some risks. There are so many risks, right? And the sharks are also available in the sea. So we need to understand, and we should have a knowledge. We should have an experience. Those type of animals are there. So hazards are there. But what happened here? Some people, maybe our student, he is going to swim. So this hazard is there. Now we have a risk, right? Hazard plus exposure. There is a hazard, right? If we have an idea about this hazard, then we can prepare for that one. But without considering all these things, what happened when we start swimming, then there is a risk. So that is the difference in between hazard and risk. A hazard is a potential source of harm, right? It's a potential thing or adverse health effect on a person or persons, right? When sharks are everywhere, swimmers can't avoid them, right? We can't avoid them. Risk is high to meet one. So hazard is there, but when we meet such animal, fish, then there is a risk. I will show you a good example now. You know what is the thing. You know the story. I am not going to tell the story now. So hazard is there, right? We have a hazard. Neither. Already we have identified this as a hazard. Gas, flames, flammable gas, and there are different gases, oxygen and unflammable gases also available, but this is under flammable gas. We know there is a risk. We know there is a hazard, right? Then what we have to do is analyze those hazards and do the preventive actions. We will discuss these things today, how to do these things, right? Hazard is there. We have identified this thing, the entire thing as a hazard, and international recognized symbols are also there. But what happened in Sri Lanka, right? This type of incidents are reporting. So what is the reason for that, right? As you are quality, as you are studying quality principles of quality management, give me your ideas on this matter, right? Do you have any idea about this matter? You know, everyone know when we are transporting, when we are storing such domestic gas cylinders, we know there is a risk. But we have identified these things, and the logo is there everywhere. You can see the logo, everything we are using. But what is happening, right? It is a risk. Now we are at a risk. What is the reason for that? We have not identified the hazards. We know there is a hazard, but we have not identified the hazards properly. Right? Therefore, we are suffering from some very serious cases in our homes and houses. And but what they are doing is, now they are going to identify the hazards. Right? That's not a scientific approach. So before sent to the market, or before, while we are processing at the initial stage, we need to identify those hazards and get the preventive actions and everything before sent to the market. If not, it is it will be a big problem. And you can see some when you go to the petrol shed, right? You can see this type of symbols are there. Some sand buckets are there, right? And some fire extinguishers are also there, right? And in your hostel also you have fire extinguishers, right? Do you know how to operate these things? So we have identified hazard. In your hostel there might be some hazards, right? Fire hazards. So what they have, our administrators and they have installed all the fire extinguishers. But they are not there. You are in the hostel. Accidentally there is a fire. Then you have to face to the problem. But you are not familiar with how to handle it. So hazard is again there, right? So we need to get the control measures and everything. I will explain, I will discuss those things with you today. So we have to identify the hazard scientifically and get the solutions also scientifically is very important. If not, we just identify the hazard, and somebody has identified the hazard, and there are some standards. So we need to fix some fire extinguishers in our premises. So that's why we have fixed those things in our premises. That is not hazard analysis. That is not belongs to hazard analysis. So if there is a hazard, there is no value for that output, right? Okay. I think now it's clear what is the hazard and what is the risk. So hazard is according to the risk definition, potential source of harm. So if we are if we not consider this hazard, and when we are going to work with that hazard without considering without identifying previously, we are going to work with an hazard. We work with a hazard, then we are at a risk, right? Here you can understand. We know there is a hazard, but we doesn't consider these things, and we don't consider these things and going to swim. But now we know there is a risk, and every day you can see some. In every day you can listen to the news, so we know how many accidents are there, road accidents and some people, they they go to little children, and then what happened? So there are so many risks. So hazard identification is very important, and even in industrial level also. So hazard analysis. Now we are going to analyze the hazards, and I am very sure that you know what is the hazard now, and hazard analysis also you have a good understanding, and you may heard the HACCP, all these things, but I am going to explain these things again. So if you have questions, please ask and raise your hand and ask. Okay. So hazard analysis means you know what are the hazards now. So we are going to analyze the hazard. A biological, chemical, or physical agent that is reasonably likely to cause illness or injury in the absence of its control. In the absence of its control. If we have implemented control measures, no problem at all, right? We have identified the hazard and implement the control measures, and we have taken actions. So there is no problem at all. But we need to identify it correctly and get the actions scientific. A hazard is something that can cause harm. Example, electricity, chemicals, working up a ladder, noise, a keyboard, a bulb key, a bully at work, stress, like that. When we refer to hazard in relation to occupational health and safety, OSHAs, the most commonly used definition is a hazard is a potential source of harm or adverse health effect on a person or persons. So now we can discuss what is the hazard analysis. You know what are the hazards and the definition of hazard analysis. According to FDA, this is the definition. So it means if we have control measures, there is no hazard. Hazard is there, but it's protected. Right? Now you know 5Y analysis, neither. What are the 5 Ys? Right here, I am going to describe further about hazard by using 5 Ys. Right? What is hazard? The purpose of collecting and evaluating information on hazards associated with the food, maybe agriculture, I just take as food, under consideration to decide which are significant and must be addressed in the HACCP plan. So don't worry, I will explain. Why we need hazard analysis? To identify the existing and also possible hazard. This is very important. We need to identify the possible hazards, right? If not, now we can start identifying existing hazards, right? When we need hazard analysis before commencing the process or while processing. I always suggest to do it before commencing the process. Who has responsible? Who have responsible? Food safety team leader or any team leader, right? Where we can apply it for the selected process or process line. So let me explain the place that if we are, so sometimes we have a processing factory. They produce different products. So for each and every product line, we need to analyze the hazards, not for the common process, right? So we can, as an example, we can take as the Nature Secret. You know, they have different products, different product lines. So if you are going to develop hazard analysis, HACCP plan, it is important to develop for all the processes, not for the common one, right? That is why I have put as the selected process line or lines. According to FDA, hazard analysis means the process of collecting and evaluating information on existing or possible hazards associated with the processing line under consideration to decide which are the significant and must be addressed, right? Again, you have example about Mavic drone. So you can see this type of hazards. Several hazards are there. Even in your mobile phone also they have the automatically generated commands. What happened? sometimes you are going to increase the volume. So there is a message. Please consider this type of decibels are there. So we recommend to maintain decibel up to 80. Like there is a message. And also such drones also you can see the hazards are there. So they have analyzed hazard, right? Before sent to the market, they have analyzed those hazards and incorporated these things into the system. Then it's when we fly it, we can see sometimes there are hazard. They have pre-identified hazards, and they automatically display those hazards. Right here, you can see an example: payload mode enabled, maximum altitude set to 98 feet, and maximum distance 164 feet. Fly in a wind-free environment to ensure flight safety. Right. So we need to adhere to these guidelines. They have identified the hazard, sometimes with the high wind rate, right, and high altitude. Might be we try to fly it up to 500 meters. Then what happened? So before that, they have identified and incorporated these things. So that is the hazard analysis, right? In Sri Lankan scenario, we can see what happened to the LP gas problem. We have identified, but we have not implemented, right? That's why I explained about the process line here. Here you can see the selected processor lines. Sometimes we can change the process. So when it comes to the LP gas issue, so they have used butane and propane. So butane and propane, the percentage according to the standards 80 to 20. Butane 80, propane 20. But nowadays, according to some gossips, right? They are using 50 to 50. So then what happened? We have hazard analysis, everything, but suddenly they have changed the process line. Then the entire process is different. So again, we have to conduct hazard analysis for that part by considering issues, right? If not, we can do some hazard analysis and we can't change the process again. If we are going to change it, then we need to do it repeat. We have very good example nowadays for lectures, so you can easily understand and the things I am explaining. So the other one is before sent to the market, the car manufacturers, automobile manufacturers, they are doing such testings, right? You can see an example for the Q5 2015. They are doing this type of crash test before sending to the market, right? Right. Fortunately, we are not manufacturing automobiles in Sri Lanka. Then what happened? Right. Sometimes there will be some accidents. So hazard analysis is very important, right? Very important in your life also. Sometimes in nowadays you have online examinations, everything you have online things. So the UGC has identified the hazards and they have sent us a circular how to do these online exams. So how to select the times and everything they have. We were advised. But anyway, still we have some problems sometimes. In the LMS also we have issues. In the Zoom also we have issues. But in your papers, it is difficult to convert it into a PDF by using your mobiles. So many problems are there. But hazard analysis, before you exam, also you can do a hazard analysis. What type of hazards we have to face in this exam? So therefore, do a hazard analysis and identify the measures for that and ready for the hazards. Right. So basically, 3 types of hazards are there: biological, physical, and chemical. So now I am going to ask a question from you. So suppose you are going to start the agriculture farm, as I taken the example in the previous lectures too. In our F40 farm, the agriculture students, they are going to start a passion fruit. They have started the passion fruit cultivation, and now we have passion fruit in the faculty. So you are going to develop, extract some carotene available in passion fruit, right? Then you all have to work together for this in developing this product. Now, now, sorry, according to the SLS guidelines, by considering those guidelines, the team is going to develop a small glass bottle for the extracts, right? Then give me some examples about biological, physical, and chemical hazards, right? For your product. What are the biological hazards? Right. Sanduni, give me an example. PST 1823, Sanduni. No idea. Uttara 1884, Uttara. Right. Good. No idea. Adushani, Manuri Dhanasuriya. You mean example for a biological hazard? Good. Okay.
Like bacteria, viruses.
Very good. Very good. And Kaushalya Amarako, give me an example for physical hazard. You are going to pack it in glass bottle. Yasuri Hettiaraj. Any? Okay, good. So,
Vibration, hazards, heat.
sorry, please repeat it.
Heat hazard.
Heat.
Oh,
Heat.
yeah.
Will also propose some soil or fruit parts, seeds also there, and biological hazards and toxicity. So thank you for your answers. So there are 3 types of hazard. Biological means maybe microbiological hazards, right? Something, some wastes of animals, right? And physical hazards means sand, metal particles, so some small stones, right? And chemical means, some chemical hazards are also there, right? So we will discuss all these things one by one, and I think you have an idea about these hazards. Hazard analysis and critical control point means HACCP. It's the method to conduct hazard analysis. It's an international recognized method, a systematic approach, and a standard method which is developed to identify, evaluate, and control food safety hazards. Right? Here also we use some preliminary evaluation, and by our experience we know something, and internal and external information, and from the chain, from the food chain, we are going to take some examples and ideas. And regulatory, statutory and regulatory and customer requirements are also there. By considering all these things, I will explain with some example how to do these things. So I think after that you can read the slide again, so it's very easy to understand. There are 7 principles in HACCP, right? First one is hazard analysis. It's familiar. You know what is hazard analysis now? It is the first one. Then determine the CCP. CCP means critical control points. Third one is establish critical limits. Establish critical limits. The definitions are there, right? Then fourth one, monitoring procedures. So we have identified sometimes there are so many hazards in our process line. Out of all these hazards, we have to identify the critical control points. What are the critical control points? Those are critical, right? Critical control points means we will discuss in detail later. Critical control point means we can't change the product again. As an example, there is a processing step called drying. Processing step called drying. There is only one drying step. So we need to reduce the moisture up to 6%. Right? Up to 6%. Then we can pack it, and there are some processing techniques again after that. What happens when we increase the temperature up to 1%? Then the texture will change, right? Moisture loss is also there. So all the texture and the product is unacceptable, not acceptable for the suppliers and our customers. So we can't change it, right? And suppose the moisture level is around 10%, but our limit is 4%, 6%. Then what happens? Then we can re-dry it and change the moisture. So we can change it, but if it is if the texture change as a result of drying, we can't change. So that type of things are critical. We can't change. So we have to remove all the entire batch. So therefore, critical control points are there. I will explain with some examples later. And establish critical limits is important. After identifying these critical control points, then we need to establish the limits. As an example, here you know the moisture percentage is 4, right? To maintain the moisture percentage here, we need to maintain the temperature limits. Might be 100 Celsius for 20 minutes. Likewise, critical limits are there. And some monitoring procedures also there. We need to establish. What are the monitoring procedures? Monitoring means how to monitor it, right? Critical control point is the dry, might be dry. Then we have established limits. The temperature should maintain at 100 degrees of Celsius for 20 minutes. There are limits. So how to monitor these things? By using the thermometer, we can check the temperature. By using clock or stopwatch, we can measure the time and monitor it. And the frequency is there. Hourly, daily, we can monitor the temperature. So we have to justify the monitoring procedures. Then corrective actions. What are the corrective actions? Corrective actions means, so we know the hazard and we have identified the critical control points and we have identified the monitoring things, everything we have done now. So corrective actions means, so sometimes the temperature may be reduced up to 80 degrees of Celsius, right? Now there is a hazard. So what we have to do is establish corrective action. So as an example, we can first what we have to do is inform to the quality assurance manager or quality control manager or the supervisor. Then please stop the machine and wait until the temperature increase up to 100 degrees and continue. Such corrective action should be there. And verification procedures. So what are the verification procedures means? Sometimes how to monitor the temperature using thermometers, right? We are using thermometers, and sometimes we can use moisture meters. We need to use. But sometimes, you know, The process is okay, but there is an issue in this thermometer. The actual temperature is 100, but it shows at 80 degrees of Celsius. Then again, we can't monitor it. Neither. So in the HACCP principle, there is a option called verification. So if we are using equipments, machines, and procedures, so verification is very important. So in this example, here we need to use thermometer or thermometers. So all thermometers should be calibrated. Right? Verification procedure means our thermometer shall be calibrated annually by you can hire any recognized institutions like SLSI or ITI. There are some institutes, so you can send your thermometers to those those laboratories and get the calibration reports. So that is verification. And record keeping and documentation is very similar, very important to monitor these things. Can you remember the Express Pearl incident? Right? I suppose that you can remember the incident. And at the end of the story, they told us that our recordings are not working. So how to solve the problem? We have no witnesses. We have no records. We have no documents, right? So record keeping is very important. I hope you can remember the first video I shown you in the first lecture about on flight departure, how to check the quality, how to do the quality assurance before departure, before the takeoff, right? So they are maintaining several documents. So documentation and record keeping is very important in quality management. Sometimes you have done these things, but how to prove? There are no proofs. There are no documents. So that should never happen. So all these principles are very important. I hope that it's very clear to you. There are 7 steps. I will explain one by one with examples later. Hazard analysis, CCP determination. There are some standard methods to determine CCP and establish critical limits. You need to establish limits. Might be a temperature, might be some time like thing, and moisture, and monitoring procedures, how to monitor these things, and corrective actions. If there are deviation, how to adhere, how to take decisions. So we should have some corrective actions, and verification procedures need to. It's very important to in monitoring these things. So we need to get these things clarified and calibrated, and we need to use some standard machines and equipments and standard procedures and record keep. You have questions regarding these principles? Then HACCP normally conducted by the food safety team leader. The tool is brainstorming. In quality assurance, always we use brainstorming. On-site verified process flow diagram should be used, and each processing steps discussed in detail, right? This is an example. I'm going to explain how to do the HACCP. This example conducted by me because I am doing some consultancies for some institutes. So this is an actual example. You can see the process line of low country orthodox black tea processing. And here you can see the detailed flow diagram, process flow chart. First, raw material receiving and quality inspection, right? Then you can read the steps one by one. There are 15 steps, right? And you can see the limits also, time and tea percentage at 60 best according to the Tea Research Institutes and Tea Board. They have developed these standards, and fermentation procedure, how to do it, 2 to 2.5 hours at room temperature, and drying temperature is also there. Then cooling temperature, everything is there. And moisture is critical before packing, right? Before sent to the market, the moisture should maintain at 5.5 to 6, right? So before starting the HACC process line, you have to develop this detailed flow diagram and recheck it by yourself and with the team. Please recheck it and then go to the processing factory, right? Then go to the processing factory and check one by one again, right? First, you can develop this referring to the process, then go to the site with responsible people, managers, supervisors, and go to the site and verify the diagram again, right? You can check it. Actually, sometimes there are some additional processes and changes in these values. So please recheck it and get their signs, signatures, and you also have to sign it by mentioning the process is correct, right? And the supervisors also need to get their signs also. You need to get the supervisors and the experts in the processing, each processing step of their signs are very important. Then go through the procedure one by one, right? The step one, can you remember what is the step one? Raw material receiving and quality inspection, right? Then as I told you earlier, we have 3 types of hazards: biological, chemical, and physical. In raw material receiving, biological hazards are bacteria, insects, fungus, bees and butterflies, and ants. So you might have some other examples. In my process, in my exercise, I have identified these things as a biological hazard. And chemical hazards, some diesel smoke is there because we are transporting raw tea leaves from the state to the factory. So diesel smoke is there. They have some toxic heavy materials, and normally they transport fertilizer and tea using the same vehicle. So fertilizer residues might be there, and grease and lubricants can be add grease and lubricants, and pesticides. Sometimes the state they have used some pesticide and insecticide, but nowadays we don't have. So in these days we can remove this part, right? We are using organic. And physical hazards in this step, raw material receiving, some sand and stone particles, coins and other plant parts might be there, dead insects and food particles, and nails and other small metal particles. Sometimes some specks are there, plastic jugs like things are also there. So that those things are belongs to physical hazards. So in one by one, you have to do this hazard analysis. I think it's clear. Then first step, raw material receiving. There are 3 hazard type, and we have identified. And by brainstorming, right? And our experience, we have identified. Then the second step also you can see what are the hazards. And the third step, the similar procedure is there, right? Right? Biological hazards, different, might be similar or different, right? And you can see they are wearing masks and hair nets and using gloves to avoid these hazards, to control these hazards. But still we have hazards, right? Then, can you remember that I told you about determination of the CCP, critical control points? We have identified the hazards. First, detailed process flow chart has been completed. Then identified the hazard for each and every step. Then we are going to discuss about CCP determination. Here you can see the decision tree is the internationally recognized one. Internationally, we are using this decision tree to make the decisions about whether it is a critical control point or not, right? So there are 4 questions and one sub question, right? Then one by one, we are going to ask these 4 questions. Do preventive measures exist for the identified hazard? Right? Preventive measures are available or not? Right? This is the first question you can see here. If yes, right? We have identified a hazard as the temperature, right? Again, we are going to use the similar example. Temperature. In this step, we have identified the hazard as the might be a temperature because of the temperature change. So, do preventive measures exist for the hazard identification? Yes. Right? We have identified the hazard. Physical. Sometimes there may be some metal particles, also a hazard. We have identified it as a physical hazard. Do preventive measures exist for the hazard? Do we have any preventive measures? Sometimes we have installed some magnets. Then the answer should be yes. If not, we have not used any preventive measures. So the sub question is there: is control at this step necessary for the safety? Right? Sometimes the steps are the hazards are there. We don't need to consider these things because the controlling is not necessary for the safety, right? But we have identified is that as a hazard, but it is not relevant to the food safety or any safety measures. If not, then stop. If yes, then we have to improve the hazard identification, right? Under no. If we have implemented any preventive measures, then the answer should be yes. Now we have installed some magnets in our processing line. So we have implemented preventive measures. So the second question, does the step is specifically designed to eliminate or reduce the likely occurrence of hazard to an acceptable level? Right? Does the step specifically designed to eliminate or reduce the likely occurrence? It means in this step, have we implemented this step to remove magnets? Right? If yes, then stop and it is a critical control point. Right? If not, we have to ask the third question. Could contamination with identified hazard occur in excess of acceptable levels, or could these increase to unacceptable levels? Right? Then again we ask that what happened when we is there any contamination with this hazard, identified hazard? If no, it is not a CCP. If yes, again we are going to ask, will subsequent step eliminate hazard or reduce the likely occurrence of this to an acceptable limit? If yes, again not an CCP. If no, it is, we call it as CCP. So I will explain with some examples. So there are 4 critical questions. As a summary, critical control point means we can't control it again, right? As I explained you earlier, the temperature is critical. In some processes, temperature is critical. If the moisture level decrease, then we can reprocess it. If moisture can decrease up to the limit, then texture also change. We can't control it again, right? And to the another example for metal, right? Right. Sorry, right? In the metal particle identification, in your process line, in this step, you have installed a magnet. Then in this magnet, you can identify the metals. You can trap the metals, right? But if we have more metals after this magnet, then we can install another magnet, right? We can't prevent it. We can install another magnet. But in the drying case, in the drying step, we can't dry it again. We can dry it again when moisture level increase. But if it is decreased up to the limit, then we can't do anything. So we have to stop. So it means a critical control point. If we have another option in a subsequent step to eliminate that hazard, we call it as a operational prerequisite program, or OPRP, not a CCP, right? CCP means we can't control it further, right? There is only one step is there to control, so we call it as critical control point. I think you got it. And the other thing is likelihood of occurrence and severity. How to determine it, right? Likelihood of occurrence means the frequency of occurrence. Sometimes this hazard might be occurred in 2 times per year, 1 time per year, maybe never happens. We have identified it as a hazard, but it never happens. So likewise, never occurring during 5 years, we call it as none. In the last 5 years, no records regarding this identified hazard. But 1-2 times per 3 years. In the previous 3 years, last 3 years, there are 1 or 2 incidents reported. So we call it as a low one. If it is a medium one, so annually it is occurring. Such hazard annually reporting. If it is a high one, you can see at least twice a year it is occurring. Sometimes might be a metal detection like issues twice a year, right? It is occurring. So we call it as a high one. So you can see numbers 1 to 4. 1 means none, 4 means high. And in this table, you can see from here to here, none is 1, 4 is 4 high. 4 means it is the frequency is high, right? Then severity. Then the severity, right? Low means the severity means how serious sickness. Okay, low means relief easily, no need to see the doctor. Just an issue, no need to go to the doctor, and it's just we can take a Pandol and then it's solved, right? Like example. Then medium one, need to see the doctor or stay in the hospital. We call it as medium severity. This is happening in the exam time, neither. Medium severity. There are so many medical reports are there close to your examinations. You have depression and gastritis and fever. Like we have identified those hazards based on our experience. Medium hazards, right? And after you miss the batch, then you have some other types of hazard like depression, and you lost your father, and you lost your mother, and you don't have any income to take to buy phone cards for the online teaching. Like hazards are there, right? Okay. Then if it is a high severity one, so it will cause for a death or disability, right? You can see from 1 to 3 here, and we have determined the limit. If it is equal or higher than 10, we call it as a critical thing, right? Then you need to multiply it 1 by 1. You know the value is 1, and 3 by 4 value is 12. 12 means it has exceeded the 10. It means there is a critical thing, right? Then the major and minor you can define according to the company, but according to the standards, you can determine the value 10 or 8 or 15. You can determine based on your process, right? But this is a standard method. You can change these parameters based on your process, right? What I wanted to explain here is we will use 4 criteria for the frequency and 3 criteria for the severity, and then multiply by frequency and severity together. Then by considering the value, you can add your own value here, but here the value is 10. Below 10, it means not a critical thing, but after exceeding the 10 or exceed value, it means it is critical. You can see CR here. So that is a critical point, right? Then I explain you 2 methods, this decision tree and this table. And you can recheck by using this table whether the decision is correct or not, right? You have taken the decision by using this decision tree is correct or not. You can check by using this table. And according to my example, you can see the processing step, raw material receiving, hazard is fertilizer residues, root cause, apply exceed amount of fertilizers, and occurrence, as I mentioned here, occurrence low, right? Low means the value is 2, right? Severity is low. So severity is low, right? Severity low means 1. 2 by 1, the value is 2, right? 2 means the rank is 2. So it is not a critical control point, not a CCP, right? It's a control point. It means we can control it. Refer guidelines, control measure. Refer guidelines means we have standards. In those standards, they have limits, right? And questions. Can you remember the 4 questions? The question 1, the answer is no. The question 2, answer is no. As a result of that, it is a CP, control point, reason, gap, and trainings, right? And the second one, pesticide residues, second hazard. Then root cause, you can identify, you can see here, application of excess amount of pesticide before 2 weeks ago. So occurrence is high, right? Occurrence is high. It means he used fertilizers at least twice a year, right? Severity also high. Pesticide means severity high. So the rank is 12. It means rank is 12 means it's a critical point. Refer guidelines, ask about the pesticide, and according to the this tree, yes, no, yes, yes, right? And here you can see I have identified this as a OPRP, not 4, but I told you if we increase the value up to 10, then we have to consider it as a CCP. But I have identified this thing as a OPRP here based on my experience, right? I know that we can control pesticide by informing others, right? By training those people. Then I am not going to use this as a OPRP. But actually, by considering this value according to the standards, it's a CCP. Likewise, we can do some adjustments by according to our experience, right? Again, the third hazard, oil and grease, occurrence is low, severity is low, so rank is second. So it means it's a critical control point. And you can see the answers for the question 1 here. Question 1, no. Question 1, no. Question 2, no. No. No, it means stop, right? Likewise, you can develop your own HACC plan. This is actually the HACC plan, right? And in Sinhala, you can see, I have given this example because most of the students are Sinhala student. So you can refer these examples too. And for all the students, you can refer the English one, right? I hope you got the point. If you need more details, you can refer these websites, FDA and FAO. But according to my experience, when I was a student, university student, our professor did this lecture series, but I was confused that I couldn't understand even one question here. Therefore, I try to give you a good understanding by using some examples and the things I have personally used, my personal examples like this. So I thought that you got the points and it's very clear to you, right? Then you will have an assignment next week. I will assign you to the breakout rooms. There are around 50 people. So we will have 10 groups. So you can develop your own HACC plan according to the topic I share with you. So please ready to that assignment and ask your friends to be there next week. Today we have around 75 people. Sorry, 45 people. And this is very important for all students. And I hope that you don't have questions. But anyway, please read this question and try to do these things yourself, right? Don't try to remember these questions. You can download these questions and everything from the internet. So don't try to remember. And the questions may change. The tree will also be changed with the time. So don't try to remember. You just type it on Google and you can download it. But thing is, you should have practice. You have to practice to do these things. Okay, so I'm going to stop today. Seems you don't have questions. If you have questions, please ask or share those questions with me. Then I will give you answers. Thank you very much for participation and attendance. Are there any questions? No. So can we get the PDF? Yes, I will upload the PDF to the LMS, and I will upload those things, the recording also to the LMS and to the YouTube also. Today I will upload all the PDF versions to the LMS. Thank you for the question, and thank you very much for your participation. And please practice. Take care.